Sec x is equal to 13 by 5 and x lies in the fourth quadrant. Find the values of other trigonometric functions. Now, when we are asked to find other trigonometric functions, we are basically expected to find the values of all the other trigonometric ratios except sec x, which is given to us. That is, we are expected to find out the values of sin x, cos x, tan x, cosec x and cot x. Now, when we are given the quadrant in which an angle lies, we should first try to get an idea about the signs of the different trigonometric functions in that quadrant. And we can do this by looking at the unit circle, which is a very useful concept. So let's say we have a unit circle here, and this is quadrant 1, 2, 3 and 4, and our angle x lies in fourth quadrant, so this could be a possibility for our angle x. So let us say, starting from the positive x-axis, our angle x, capital X, would look something like this, right? And we can immediately guess that in this quadrant cos x is going to be positive, because cos x would basically be the projection of this particular line segment on the x-axis, which is on the positive side. And sin x would be negative, because sin x is the projection of this particular line segment on the y-axis, which is on the negative side. Therefore, cos x is positive, and so would be sec x, because sec x is 1 by cos x. And that is also confirmed from the data given in the problem. Sec x is plus 13 by 5. And as we said, sin x would be negative, and therefore so would be cosec x, because cosec x is 1 by sin x. And how about tan x? Now that would be negative, because we know that tan x is sin x by cos x, and sin x is negative and cos x is positive, and therefore even cot x would be negative. So let us answer this question now. We are given that sec x is 13 by 5, so we can immediately find cos x as inverse of sec x, so it would be 5 by 13. And now we can either first find tan x by using the expression tan square x plus 1 equals sec square x, because we already know sec x, or we could find first sin x using the expression cos squared x plus sin squared x equal to 1. So let us use the expression tan squared x plus 1 equals sec squared x. So we get tan squared x equals sec squared x minus 1, which is 13 by 5 whole squared minus 1, and therefore tan x is the square root of that, which is square root of 13 squared by 5 squared whole minus 1, which comes to 144 by 25 square root, which is equal to plus minus 12 by 5. Now we know that tan x is negative, it cannot be positive, so therefore we can say that tan x is minus 12 by 5, and therefore cot x is inverse of tan x, which would be minus 5 by 12. And now what remains to be found are sin x and cosec x. We know that sin x equals tan x multiplied by cos x, and we already know those values. Tan x is minus 12 by 5 and cos x is 5 by 13, and by multiplying them we get sin x equals minus 12 by 13. And lastly, cosec x is inverse of sin x, so that would be minus 13 by 12. Now a quick way to check the consistency of our answers would be to match the signs of these ratios that we have found, cos x, tan x, cot x, sin x, cosec x, with what we figured out from this unit circle logic here. And we see that the signs actually match with what they should be for the fourth quadrant. Okay, so let us now move to the fifth question. What are the